Boys and girls, welcome back to the drive-thru, a special Friday edition. As always, sponsored by the deli. Hungry? Stop by the deli. Get yourself some Cool Ranch Doritos. The original, not baked. The fatty, delicious Cool Ranch Doritos. Okay, we're working in our second lecture involving the cross product, and we want to be able to show you why magnitude of u times magnitude of v times sine of theta is equal to the area of a parallelogram. Okay, so if we have a parallelogram defined by u and v and some angle theta that's in between those vectors, remember that v is a vector and that u is a vector, but the magnitude of v is just the length of that segment, okay, if you will. And the magnitude of u is the length of the base. Okay? So just from trig, we know that in order to find the height of this parallelogram, okay, we would say sine of theta is h over v. Okay, so the h is equal to v sine theta. Now we got to be careful because when we talk about v, we're talking about the hypotenuse, and when we were talking about SOHCAHTOA, we really only cared about the magnitude of the hypotenuse and the magnitude of the hypotenuse. So these are all magnitudes now. That's what gets confusing. We're working with numbers when we do trig, not vectors. So we now get that h is the magnitude of v times the sine of theta. So then the area of the p-gram is equal to the base times the height. Well, the base is the magnitude of u. Okay? The height is magnitude of v sine theta. So hopefully you understand. You probably maybe already understood that. Why magnitude of u times magnitude of v times sine of theta equals the area of the parallelogram. Well, that actually isn't really new, but here's what is new. Magnitude of u times magnitude of v times sine of theta is equal to the magnitude of the cross product. So the easier way to find the area of a parallelogram in 3 dimensions, so that's a weird term, okay? A parallelogram is 2-dimensional. But let's say this parallelogram is in 3 space. The easiest way is just to find the magnitude of the cross product. That's that funky proof that you were just reading. So I'm going to go over why that is after this lecture, but I'm not going to go over it on this video because it literally is going to take me 45 minutes to do the proof. I'm not going to do it all, but I'll kind of set it up. Well, it's weird, Julia. They don't use 2 lines in our book, so I intentionally left it like that. I wish there were 2 lines. There is? They do? Okay, good. 2 lines it is. Do they?
Yes. When they do the number 4 equation itself, it's 2 lines around u.
Yep, you're right. Good. Thank you. All right, good. All right, we're moving on. Here's an example that you guys can just kind of do with me. You should have a good idea how to do this now. One thing that I'll tell you is make sure that you always keep in mind which, like if they give you 2 components, put the 0 in the right spot. Sometimes they won't give you the j, and so you got to put a 0 in the middle, you know what I mean? That's an easy thing to screw up. So we're just practicing our cross product right now. I, j, k. We have 1, -4, 1, ij. So then we have 2, 3, 0. We want to take the determinant of this. Okay? So it's I times 0. Okay, 0 minus 3 minus j times 0 minus 2 okay, plus k times 3 minus a negative 8, so 3 plus 8. So we end up getting negative 3, positive 2, positive 11. They ask for a unit vector in that direction. Okay, so we need to find the magnitude of this, and that's the square root of 9 plus 4 plus 121. So radical 134. And we will just write the answer then as negative 3 over radical 134, comma 2 over radical 134, comma 11 over radical 134. And now we've got a unit vector. On the outside, that's a totally a fine way to write it, AJ. We could also write this as 1 over 134 times negative 3, comma 2, comma 11. Those are equally preferable. Maya?
Can we say plus or minus since it doesn't?
Well, it says find a unit vector, and us being Americans, we have the right to be minimalist. So I certainly have answered that question, but if we wanted to get it both answers, that would be exactly what you would do. Okay? Very good. Very good. And if you didn't follow that, that's because U cross V is equal to minus V cross U. Okay? Good job. All right, moving on. Okay, so this is where I might be using words that would like offend the physics people, because the math book does physics a certain way and uses like certain units to like represent things that maybe don't really exist in physics, or they don't like to use in physics. So we're going to try to talk about torque, but we're going to talk about it in the book refers it to as the moment about a force. Or the moment of a force about a point, excuse me. The moment about a point. Okay? And so this is how this is written. The moment represents torque, this right here. And it's the cross product of basically our lever and our force, if you will. Okay? So, it says a vertical force of 50 pounds is applied to a 1-foot lever that is attached to an axle at a point. All right, let's see if I can draw this. We got X, Y, Z. You've got a lever. Okay, it's 60 degrees between the YZ axis and the lever is being pulled in that direction. The force that we're applying is down negative 50 pounds. Okay. All right, so we've got to get these things in vector form. Okay. And for the record, if you prefer to do these in a manner that you learned in physics, because this is still in 2 dimensions, if you can do them the way you prefer to do them in physics and you get them right, well then I recommend that you do them that way. That's no problem at all. Okay? We're going to represent our force as 0, 0, negative 50. Okay? So now we've got to represent our lever. So we'll just call this PQ because that's what it's called in this little equation up there, so we'll kind of learn how to use it. All right, well, if we look at our lever, it doesn't come out at all in the x direction, so it has no I component. Okay? And then if we treated the y-z axis like it's our old school x, okay, so then y would become our x, right? So weirdly, y is going to be cosine, right? So it should be cosine of 60 here, and then sine of 60 for our z. And that will actually be a unit vector, but only because this is a 1-foot lever, right? So if this was a 6-foot lever, then you'd have to draw a 6 out here. Does that make sense? So that's kind of something that when you're reading our math book, they don't show that, and so that's where you got to kind of be experienced to read a textbook. Okay? We'll clean these up. What's cosine of 60? 1/2. And so the other one's radical 3 over 2. Okay? So we're just going to cross these. All right, so is that what it asks? Oh, it's PQ cross. Yes, you're right. PQ cross. That's right. We got the order will matter. So we got to do 0, 1/2, radical 3 over 2, because that is PQ, and then F is 0, 0, negative 50. Okay, so I times negative 25 minus J times 0 plus K times 0. So the resultant vector is negative 25, comma 0, comma 0. Let's go back up to our picture and see if that makes sense. I like it. That means all of our torque is rotating about the x-axis. That's how it should be. Okay? Eventually, we could figure out things that were spinning in any direction. All right. So if they ask for the magnitude, this would be easy, but the magnitude of torque would be 25. You would just take the magnitude of our moment about the point. Okay, we'll get better at those. Hopefully you guys will ask some questions and we'll put up a couple more examples of those today and Monday. Finally, you can use a combination of the dot product and the cross product to find the volume of a parallelepiped. Okay, there's your new favorite math word. A parallelepiped is like a three-dimensional solid. It's like a parallelogram. It's like a cube that doesn't have rectangles as its sides, or doesn't necessarily, so it could look like this. Uh-oh. Something like that. Whoops. Something like that. Ish. Okay? So it's determined. All you need to know is it's determined by three vectors. You got a U, you got a V, and then now we have a W. Obviously this works for like prisms as well. A prism would be considered a type of parallelepiped. Okay? Well, if you just think about this, the magnitude of V cross W gives you what? The area of the base, okay? And then you dot that well, the magnitude of V cross W would actually give you the area of this side of it. So we'd have to call that the base, okay? And then when you dot that, remember, the V cross W gives you a what? A vector, okay? So we're going to get a vector from this, and then we're going to dot it with U, which virtually multiplies it by all of the parts of U that are traveling in the same direction as the vector that's orthogonal to V and W. Does that make sense? Let me say that again. This thing right here, the result of that is a what? Is it a scalar or a vector? It's a vector. It's orthogonal to both. So if I underline it in red, it is this vector that is orthogonal to both, okay? So if I dot product this red vector with the U, it's going to give us the amount of U that is traveling in the same direction as the red vector. Well, that's good, because that's going to be the height of the parallelepiped, because it's perpendicular. And that's all you're doing. You're just doing area of the base times the height. I mean, that's really what you're doing. Okay? So, we'll do this, I guess, because you can't have enough practice on cross products. Yeah? Cubes are a type of parallelepiped. Yep, a type of prism, which is a type of parallelepiped. Everybody give Miss Kemke a round of applause, please. Thank you, Miss Kemke. Have a great weekend. Is Penn State not playing this weekend? Temple. All right. I know you will. See ya. Okay, so first of all, it doesn't matter what order you do this in. Okay, so there's something in your book that says that. You can kind of read up on that. All right. Can we just do U cross V? All right. I, J, K, 3, -5, 1. If you started doing it a different way, Ratchet, it doesn't matter. I want you to keep doing it that way, and we'll make sure we get the same answer. Okay, I'm just not following the equation directly, because I'm showing you that it doesn't matter. Okay, so you get I times 10. Oh, here we go. I'm going to try to do this without writing down my subtraction. Let's see if I can get it right. 10 minus 2 is 8, minus J times -6 plus K times 0 minus 6. No, K, yeah, that's right, that's right. So I believe it is 8, +6, -6. Okay, now we're going to dot that with our W. So 3, 1, 1, dot 8, 6. Did I mess it up? Okay, 6 minus 0, not 0 minus 6. Thank you. Thank you, thank you, thank you. So that just shows you I wasn't ready for that. I should write out my work, which I already knew. Okay, so you get 24 plus 6 plus 6, and the volume of that parallelepiped is 36 cubic units. Not bad? All right. We got about a day and a half to get working now. Boom!